Welcome to the YouTube channel, Simulation Tips for CAD users. In the next 10 minutes, we'll see how we easily can create a mechanism with flexible hoses, tubes, such as hydraulic hoses in a mechanism, and how we can see the real world behavior. Let's go for Creo Parametric to build that kind of mechanism. We're starting here, let's say, with the main mechanism. I already assembled one arm by default constraint, and I'm bringing in the next arm. This is a sub-assembly, and I'm connecting it in that area with a pin joint. I'm selecting here the cylindrical surfaces, and in set direction I'm taking those 2 points. The pin joint is done, and I can, let's say, reference my angular rotation of that pin joint. I can switch the direction here, and I can bring in some limits. Let's do the limits between 0 and 135 degrees, and therefore we can see here this limited movement. Okay, as a next thing, I'm going to build my tube. Therefore, I'm opening another assembly. It's called hose segments here. And in that assembly here, I'd like to build that kind of mechanism which has that behavior. Let's start from beginning here. So I'm going to assemble again here let's say a dummy part, and this dummy part should rotate around that axis. Therefore, I'm creating again a pin joint, and in, let's say, set direction, I'm taking those 2 points here. Again, here in the placement, I'm defining some references for the rotation, and in that case, my allowable rotation is minus 45 degrees and plus 45 degrees. Therefore, I can see right now that behavior. But with that, let's say, segment, I'm going for my mechanism. Here we have that segment. I'm going for that mechanism, and I'm bringing in here some springs. I'm creating here a spring, rotational spring here in that area, and quite important is to set here the on-stretch position to 0, and let's bring in here a certain stiffness of 100. Parallel to that one, I'm bringing in a damper, rotational damper, again to the same axis with a certain value. Okay, with that kind of segment, I'm building my flexible hose. Okay, here I have another assembly. This assembly is empty. I'm assembling in that area here my segment I created before. The first segment goes to default constraint, and the next segment will be placed to that moving dummy part. Therefore, I'm displaying my coordinate system, and I'm assembling the next hose segment. In that case, I will use a connection called Weld Connection, and in that Weld Connection, I'm bringing in maybe from my segment here, my basic coordinate system. This should connect, let's say, to the coordinate system of this, not the segment, of the pin joint of the segment. So unfortunately, it seems to be not displayed. Okay, I'm displaying that coordinate system, all of them, one. Okay, let's see them here. Okay, and now I'm taking that the second segment here, and I'm going to right mouse button to repeat it. Okay, I will add some new connection, okay, to that pin joint. So in the end now I have 15 segments. And then when I'm going with that guy for my mechanism application, here I need my mechanism dynamics option. Then I can set up, I can move, let's say, all that kind of stuff. But when I do right now an analysis, let's do a static analysis, and I run that analysis, my hose will be straight, because in the straight position I created the zero position of my springs and of my dampers. Now it's of my springs. Now I'm taking that hose to my main assembly. This is my main assembly, and now I will connect that hose in that area to these fixations here. I'm assembling the hose with the 15 segments. Okay, in that area, and again I will let's say take here the basic coordinate system to that coordinate system here. Therefore I'm using again a weld joint of my mechanism. Okay, that guy to that guy here. Okay, it will be connected. Now I can, let's say, move that component, and in that area here in the front I will place right mouse button, a new set here, and I will again use the set here of welding constraints. I will not take the dummy coordinate system, I will take the coordinate system of the segment. This should connect here. Now they're connected, and now I can see, let's say, more or less the behavior of that one. It's not the natural behavior of that guy. In order to get the natural behavior, I have first, let's say, create an initial natural position of that one. Therefore, I'm moving that guy to zero position. I will access mechanism, and in the mechanism environment, I'm creating here a new static analysis. In the static analysis, let's name it static. Okay, I will make a body lock, middle mouse button to that guy here, okay. And with that body lock, I'm running that analysis. And you see, okay, you're getting a natural position of that guy. I'm doing it again, I'm running it again. And we'll see, okay, didn't work because here I was in a end position. I'm running it again. So, and now we'll see, let's say, the natural position, the starting position of that one. I'm going to save that starting position as a snapshot. I call it maybe start. Okay. And that start position, with that start position, I'm creating an initial condition for my dynamic analysis. Okay, let's take that guy here. I created before, and now I will run my dynamic analysis. In order to be able to run that analysis, I'm needing here an additional motor. I'm creating that motor. I'm setting a profile with a table. I need here 2 lines, and I wanna create during 10 seconds a movement of 135 degrees at that pin joint. Okay, and now let's create here, let's set up a dynamic analysis, maybe during 10 seconds. Okay, the motor is active, and here we have a movement of 10 seconds, and I will use here this initial condition. And I'm going to run that analysis, okay? Running is on the way, and during the movement we can see the natural behavior of my component. Unfortunately, we see that we have here a interference around that area. Okay, we'll get an interference, and I can add here an additional, let's say, connection. We call it cam connection, and with the help of that cam connection, with that predefined surfaces here, I will not allow to get any, let's say, interferences between the hose and those segments here. Let's select one of that segments here. Okay, let's flip that one. Let's enable liftoff, and let's create the second cam connection. In that case, it should be between, again, the same surface here and let's say here that area of that guy. Be careful always to flip that direction and to enable that liftoff. And when I'm starting again my dynamic analysis, we'll see that we have a perfect movement and the hose will not go into the other components because there is a lift off cam connection. Let's go for the playback. Okay, of course, of the dynamic analysis, and then we can see the natural behavior of, let's say, a flexible tube in a mechanism. And here we can see that it's not allowed to get any interferences between tube and mechanism. So that was all of that nice tip of this flexible tube. If you like it, please subscribe for my YouTube channel, or if you have any further questions, you can send me an email. Thank you very much for your attention and have a great day.